All right. So this is a problem about Thales circles. It's a little bit straightforward because it mentions Thales circles. You will see applications where you're going to be the one who has to come up with the idea that, oh, this problem has to do with the Thales circles. So this one basically states that if you draw in any triangle, if you draw the Thales circles of two sides, then there's going to be one obvious intersection point, but the non-obvious intersection point is going to be on the third side. Let me just draw a picture, just a little plan. So if we draw the Thales circle of this side and say this side, then this is the obvious intersection point. And the problem states that prove that this point, in fact, is on the third side. So this picture is pretty bad. Or the problem is incorrect, one of those two. Let's see. So suppose, let the 3 points be given. Any triangle at all. And oh, should we construct a Thales circle? How would we construct a Thales circle? If we can do a perpendicular bisector, we can do it, because all we got to do is construct a perpendicular bisector for the only sole purpose of finding the midpoint. Oh, yeah, I overdid that. See, we try to not draw things that are going to be just clutter. All we needed was the midpoint for the Thales circle. Let me make the triangles, two sides darker. AB and AC. Okay, so because once we have the midpoint, we can draw the Thales circle. All right, so that's one Thales circle. And then we're going to do the other one. So we just needed the midpoint, because that's going to be the center of the Thales circle. All right, here are the circles. And so, and now you understand why we draw just a little bit, because it gets crowded after a while. So we have two sides of a triangle. This is the third side. I intentionally didn't draw it in. And we drew the Thales circles for line segment AC and line segment AB. Now, one obvious intersection point is A. And our task is to prove that this other intersection point falls on line segment BC, falls on the third side of the triangle. Okay, so let's call this point P, and let's consider first triangle APC. This here is a right angle. That's what Thales' theorem is about, that anywhere on this circle, if you connect any point on this circle with the two ends of this diameter, what you get is a right angle there, is a right triangle. And not just a right triangle, but the right angle is at point P. And then we're going to do the same thing with triangle ABP. That too is a right angle. And now what we're looking at is there is line segment CP and there is line segment PB, and the angle between them turns out to be 90 plus 90, 180 degrees. So it's a straight angle, so it's right on it. P is on the third side, line segment BC. And also notice that P is not just any point, but this is the point that we get when we draw in the height. This is the height drawn to this line segment. So that's how that one goes. Thank you for watching.